I am a firm believer that in the U.S. at least, our agricultural research and extension programs at our land-grant universities here truly are national treasures. But of all the outstanding research that's done every year at these institutions, why doesn't more of it get commercialized?
We came out of the university with a material that did a really good job at binding and releasing phosphate in a controlled manner. But that's what we had. It's been quite a long journey over the last 8 years getting this from the lab into the field, from the field into production, and then scaling production to ultimately manufacture and replace commodity phosphates like MAP and DAP.
That's Hunter Swisher, founder and CEO of Phospholutions, which initially commercialized research done at Penn State. Then we move west a little bit to where Jackson Stansel formed his company Sentinel Fertigation based on research he was doing as a grad student at the University of Nebraska-Lincoln. He also focuses on nutrient management, but specifically on irrigated crops.
Really seeing those numbers is what ultimately said, okay, we're getting to the end of a grant cycle. We don't want this technology to die because it has really great potential to positively impact farmers and agronomists. And really the only way to take that forward was to found a startup company.
Two impressive founders commercializing university research to solve major problems for farmers on today's Future of Agriculture podcast. Hey, fellow Ag Nerd, thanks so much for joining me. My name is Tim Hammerich, and every week you and I get to hear from the founders, farmers, innovators, and investors, the people shaping the future of the ag industry. Now, before we dive into today's episode, I want to take just a moment to thank our quarterly presenting sponsor, which this quarter is Headstorm, engineering growth for the farms of tomorrow. Headstorm is a full-service technology consultancy with been there, done that knowledge and expertise in the ag industry. The team at Headstorm knows which digital strategies work and which ones don't work based on the competitive landscape across broadacre, specialty, and animal ag industries. Headstorm provides a holistic and actionable technology roadmap that bridges the gap between strategy and implementation. From inception to execution, they're going to help you play to your strengths, mitigate your weaknesses, and make technology your unfair advantage. Learn more about them at headstorm.com. That's headstorm.com. I'll leave a link for it in the show notes, of course. Thank you so much to Headstorm for supporting ag innovation and the Future of Agriculture podcast. All right, now back to today's featured conversation with Hunter Swisher and Jackson Stansel. I recorded both of these interviews in person in San Francisco during the World Agritech back in March, and originally I didn't really have any intentions of putting them together into one episode. But because of that busy week, we got short interviews from both of them, and it just made a lot of sense. They're both great examples of innovation in nutrient management, as well as great case studies of what it looks like to commercialize technology developed at land-grant universities. So it just seemed apt to create an episode with these two interviews together. Plus, I just think it's cool that they were both students, in Hunter's case, an undergrad, in Jackson's case, a graduate student, when they sort of came across the technology and ultimately launched their business. I'll formally introduce Jackson to you later in the episode, but first you're going to hear from Hunter Swisher. Hunter is the president and CEO of Phospholutions, which he founded prior to graduating with his bachelor's degree in plant sciences from Pennsylvania State University. Phospholutions is a sustainable fertilizer company with the mission of improving global phosphate efficiency. He does a great job today of talking about some of the major issues with the status quo when it comes to phosphorus. And if you haven't looked into it, it is pretty eye-opening. We'll start things off by going back to when his eyes were first opened to this issue and how that education changed the course of his career.
I was actually sitting in college about 8 years ago, and we learned all about how global phosphate use, the OPEC of the future, my professor said, was going to be about phosphorus, not petroleum. Really curious, learned a lot about this issue. Globally, it's a finite resource, something that we mine in only a few select geographies around the world. And we're using this at a pretty alarming rate. It's a non-renewable resource. It's the second largest nutrient needed for food production. And we're basically dumping it into the bottom of the ocean. So for us, this was something I got pretty passionate about pretty early and had the opportunity to think about how we solve this through technology. And for us to start, it's trying to tackle fertilizer efficiency. So 90+% of what's pulled out of these mines gets applied to the farm field in some form and fashion of very inefficient sources of conventional commodity phosphate, but only 10% of it gets into the crop.
And why is that only 10%?
Phosphate's an extremely reactive nutrient, something that likes to grab on and hold on to the soil pretty tightly, and that soil doesn't do a very efficient job at releasing it throughout the growing season. So what we do is we try to get more of what's applied actually into the crop by preventing it from being tied up in the soil.
And nitrogen gets all the love, right? I mean, there's probably a dozen nitrogen startups out there, trying to figure out ways to pull nitrogen out of the air, better than the Haber-Bosch process. Phosphorus, though, it doesn't seem like there is as many people attacking it. Now, I know by volume we use less phosphorus, but as you're saying, we mine this stuff. And so it is a very finite resource. Why is it that there are so few, relatively speaking, companies attacking phosphorus?
So first off, I think it's a challenging one. Phosphate is not in the air. We can't engineer a microbe to pull it out of the air and convert it in the soil. It is a mined resource. It's something where we'll never get away from applying this mined resource to the field to make up for what the crop removes. The idea, though, is how do we actually improve the efficiency of it, because it's very inefficient today. We think it's relatively untapped space as well, Tim. And I think that's an advantage of being in this space today. But the problem is all the solutions that have come out in the market today are downstream. So they're all additional steps required to modify product to the retailer. It's asking the farmer to do something different, blending something different, coating something different. What's unique about our solution is that we actually target all the way upstream to the phosphate production level. We integrate our technology into the traditional, conventional phosphate sources today. It's made the same way, shipped the same way, applied the same way by the farmer, but we just use less because of our technology being embedded into that granule allows for phosphate, a much higher percentage to get up into the plant and less of it to be tied up in the soil.
And when you say a lot of the other solutions are downstream, you're essentially talking about kind of recycling, right? I mean, recycling phosphorus in a way.
So there's recycling solutions. There's some microbial solutions. The challenge with those is that you can solubilize phosphate in the soil all you want, but you still have to eventually reapply phosphate to make up for what the crops are moving. So we'll never get away from using these sources. There's materials that are being applied to the surface of these fertilizers. But again, ask the retailer to do a coating, blend something, add an extra step to either the retailer or the farmer. You got to find another bin to store these things. It starts to become a little bit of a challenge for adoption.
Yeah. Yeah, I mean, that to me is kind of the nightmare scenario. Or we're mining a finite resource, one that we absolutely need for the crop, one that we can't really build up in our soil over time and call it good. We have to keep applying it, and one that we're wasting 90% of. So in comes Phospholutions. You're sitting in college and you find out about this big problem, and you find a solution from a college professor. Am I remembering that right?
That is correct. Yeah. So there were some patents developed by a professor of mine at the university. And as quite a busy and pretty world-renowned plant nutritionist, commercializing that technology was not front of mind for him. Had the opportunity to kind of come in. There was a big entrepreneurial movement within Penn State coming from the top down. A lot of resources popping up for undergrads to leverage things like this to start a business. In 2016, we spun it out, licensed it from the university, and have been on a journey ever since.
Okay, so why aren't Bayer and BASF and Syngenta finding these professors that want to develop this technology but not commercialize it and say, hey, we'll do that? Why does an undergrad get this opportunity instead of a big multinational going after it?
Look, I'll tell you this. It is a lot of work to move it from the idea phase that it worked in a lab to being a commercialized product. And typically it's not corporate strength in taking something so early stage and bringing it to market like that. It's not unheard of. It does happen. But I think it's something where, there's a reason why startups exist in this space. Developing new things takes a lot of time, a lot of money, and there's a lot of risk involved. And sometimes it's better to watch these things externally develop, and other ways in which you can engage, whether that's licensing, M&A, buying the company outright. There's a lot of things that can be done once that de-risking has occurred.
Right. And that's the hard work you've been doing. So talk about where the company is now. Phospholutions, what is the flagship product? Is Rhizozorb, is that right?
That is correct.
Yeah, Rhizozorb. What is exactly Rhizozorb, and how's the market reacting to it?
Yeah, so look, we came out of the university with a material that did a really good job at binding and releasing phosphate in a controlled manner. But that's what we had. It's been quite a long journey over the last 8 years getting this from the lab into the field, from the field into production, and then scaling production through partnership to ultimately manufacture and replace commodity phosphates like MAP and DAP. So where we're at today, we sell a product called Rhizozorb. It's an 839.0 guaranteed analysis. So it has 8% nitrogen, 39% P2O5. It is a replacement for MAP and DAP. It's being essentially applied by retail to the farm field. It's something that we're now actively pushing out through distribution. Last year, we launched kind of a soft launch demo year. This year, we're out fully selling product through some pretty major retailers across the country.
Great. And what is the impact on the farm of using Rhizosorb? If I'm a farmer, what's going to be different?
Yeah. So the nice part is what's not different is it's still a granular product. It's still showing up and applied the same way. And it feels just like MAP and DAP. Difference is slightly lower guaranteed analysis. The product is much higher in efficiency. What we end up seeing is that growers are applying less phosphate. We've shown that we can apply up to 50% less P2O5 per acre and still achieve the same or greater yield, ultimately saving the farmer money per acre to get the same productivity outcome. We do see some small incremental yield gains in our trials. So we're seeing that between the yield bushel increases and the cost savings benefit, growers on average are taking home about $20 more an acre in ROI.
Wow, that's great. And so, yeah, essentially I'm going to apply 50% less. It's by volume probably more expensive, but not double the price.
That's correct. So when you look on it from a per acre basis, it's cheaper. When you look at it per ton basis, it's more expensive.
All right. And help us understand what's happening beneath the soil surface here is why is it so much more efficient than our normal phosphate?
Yeah. So traditional MAP and DAP, 95% plus soluble. And when I mean soluble, it's in the first 10 days they're solubilizing. Challenge is 75% of it's applied in the fall. And when phosphate's solubilized in the soil, it reacts with everything and binds up, and in some cases, irreversibly binds to the soil. It will never release, or if it does, it's going to take 10 years. So the challenge there is how do you keep that phosphate ion available to the plant, but not directly available in solution? So what we do is we essentially, during the production process, take phosphoric acid during the MAP and DAP production and essentially adhere it to the surface of our raw material. That surface chemistry binds the phosphate. As it gets delivered to the soil as a granule, it starts to release that phosphate only as the plant is depleting that soil solution. So you've got phosphate available only directly in solution to the plant. Every time the plant removes a unit, the product's releasing a unit back into solution to make up for what's been removed. So it's this equilibrium or this concentration gradient that's established between the surface of the material and the actual soil solution where the plant's removing nutrients. So very smart release. It's driven more based on plant needs than, say, environmental conditions, and it keeps that phosphate available to the plant throughout the entire growing season.
And what's the window for that smart release? Like if it doesn't get released right away, could it get released later in the season or the following season, or is there kind of a window there?
Yeah, if the plant's not removing phosphorus, the product's not releasing it. And that's kind of the key. On the contrary, conventional chemical fertilizer, all it takes is water and you're releasing the phosphate. There can be a plant in there soaking up the nutrients or not. It doesn't make a difference. Conventional phosphates being solubilized.
So as far as kind of adoption and rolling this thing out, where are you seeing the light bulb come on for the most farmers? Is this a Midwest focused product, or are you seeing it in high value crops as well? Or
we're primarily focused on big row crops. We have seen some other specialty crops start to adopt the technology as well, specifically like potatoes, where they're very high phosphate consumers. What we're seeing now is that, look, retailers like the product because it's more efficient. You're using less volume to service the same number of acres. There's a lot of operational efficiency that goes with that, but also there's just more margin. To be quite frank, you make more money off of selling our product than you do MAP and DAP. Second of all, the grower, it's an easier sale. The grower, you go out, hey, you want to use this stuff that we used last year, you want to use this new product. It's still MAP. It's got this technology in it. It's more efficient. We use a little less per acre. You save money per acre. You get the same outcome. The sustainability side, we've actually been surprised to see how much the channel is interested in the sustainability aspect. We built this product based on being more economically viable for both the distributor and the grower. But ultimately, there's a massive impact on carbon emissions. Phosphate's a pretty difficult nutrient to reduce the carbon footprint because it's mined and it's shipped in bulk. What we found is that we launched a third-party life cycle analysis. Our product reduces carbon emissions per acre by over 45% compared to MAP and DAP. That's both from removing higher carbon intensity raw materials off the farm field and replacing it with a lower carbon intensity product, and the overall reduction in volume. And then lastly, third-party study funded by the new fertilizer industry shows that we can actually reduce runoff potential by 78% compared to MAP and DAP, which is a dramatic improvement in how much is ultimately getting into our waterways. And by the way, the product makes everyone more money involved.
That's the key, right? I mean, the reason why all that is cool is because it's not what the product stands on, right? It's the money savings, and then you get the benefit of all that sustainability. Because what I hear a lot, especially in events like this, is like the sustainability story is everything, and you realize like, okay, that's never going to play out if the economics don't work. And so the economics here are pretty compelling to me.
Yeah, and Tim, I think for us, it's certainly been something that's been to our core. We started the business based off of the mission to try to solve this global issue. The reality is we build a product that has to make not only financial sense, but it has to be easy.
And are you manufacturing this yourself? Or are you working with kind of legacy? I don't want to say they're mines, not manufacturers, but legacy companies. Yeah.
Yeah, they're both. So yes, we do partner in this case. So we don't manufacture the finished fertilizer product. We work with producers. The interesting part about this is producers also see more value in the product. They're cutting back on their most expensive raw materials. They're replacing it with a cheaper product that ultimately ends up creating more value throughout the overall on a P2O5 basis. Extends their mine life, which was one of the components we didn't touch on in the beginning. Mine life is everything. In the US, we've got estimates between 30 to 40 years left of phosphate. Once we are out of that phosphate, we're relying on importing phosphate from Russia, Morocco, China, and Saudi Arabia. I mean, those are the 4 other locations where there's massive reserves that are being mined and really brought to market at scale. As a large agricultural country, it's pretty alarming. This is a critical resource.
And most of the phosphate that's utilized in North America, is it mined here or is it shipped in from other countries?
The market has imported phosphates for sure. But the reality here is that, look, we've got big domestic reserves. We're just depleting them very quickly.
Yeah. And this peak phosphorus thing, I mean, it's something that I'm surprised we don't hear more talk about it, because whereas oil, you can kind of drill deeper if you have the money, or you can kind of, use some of these other techniques. But with phosphate, my understanding is like we kind of know what's out there. I have a pretty good sense of what's out there and what's accessible. And it's not like we just spend more money and find more. Is that right?
You're absolutely right. And the alarming part is that as it enters that waterway and gets out ultimately to the ocean, it's going down. And these are reserves that have built up over millions of years from ancient sea life. Like, this is something that isn't going to come back. And there's not like a renewable source. It's not like oil where we can just find other ways to generate energy. Like, phosphate is the backbone of your DNA. It's part of the energy transfer within your cell. Every living thing from grass to you as a human need a substantial amount of phosphate within your body to live. And once we run out of this resource, I don't understand how we're going to be able to feed the world. Now, again, this is kind of an existential question that's a couple hundred years out from being a reality to us, but you don't get ahead of this stuff, overnight. So
it is alarming. Well, you alluded to this earlier, but one thing that's interesting about your product is it is not in competition with other phosphate solutions. It's complementary. It's about efficiency. Are there other solutions that you think work really well in tandem with yours, to address this big, as you said, existential problem?
Yeah, absolutely. I mean, for us, I think we see that there's potential for combining solutions out there. One of the things that we see opportunity in is in the microbial space. We think that these tools can be helpful. I think the challenge with those tools is that you can solubilize phosphate all you want, but phosphate fertilizer doesn't have a problem being solubilized. I mean, yes, it gets tied up in the soil, and yes, we need to solubilize it to mine it from the soil. But the reality is we're focused on making sure that what we keep applying each year, that we just generally have more availability. We see that there's opportunity to combine those two solutions to both draw from the soil and to make what we apply ultimately more efficient as well.
Well, really interesting and important work they're doing over there at Phospholutions. That's it for my interview with Hunter. He did add, though, that they've recently qualified for an enhanced efficiency fertilizer recommendation from USDA, which opens them up for some cost share opportunities. So that would mean even better ROI for some farmer customers. You can learn more about what they're doing over at their website, phospholutions.com. We'll link to it in the show notes, of course. And speaking of solving problems that help with both farmer profitability and environmental stewardship, we're going to jump to our next interview with Jackson Stansel, who's the founder and CEO of Sentinel Fertigation. Sentinel Fertigation leverages satellite imagery and geospatial data to empower precision nutrient management, particularly for nitrogen fertigation, so in irrigated crops. Originally from Dothan, Alabama, Jackson did his undergrad at Harvard, where he also played football. He was pursuing a master's degree at Nebraska when he turned the research he was doing into a business and decided to put his PhD on hold to commercialize the technology.
So I went to the University of Nebraska in 2019 to get a master's in ag engineering, and was fortunate enough to jump in on a project that was sponsored by the Nebraska Corn Board, as well as the Dougherty Water for Food Institute. And it was essentially targeted at how can we use multispectral imagery to determine the correct timing and rate for nitrogen fertigation events. With Nebraska being the most heavily center pivot irrigated state in the country, most irrigated corn, this is a pretty critical need for the state. And Nebraska is also facing some acute groundwater nitrate challenges. And so there was a lot of energy around this project. I got to step in as a graduate student that led the on-farm research and development of the agronomic framework that we were going to use. And that also coincided with me basically developing the software to automate a lot of the processes from image collection through prescription transfer to the end user, the farmer. And so really the project itself was focused on fertigation from the very beginning. And so that's what we've continued to focus on. But really what fertigation provides is the ultimate control pathway for nutrient application in the field. In general, fertigation is combined with other application techniques, side dress applications, upfront anhydrous applications at planting, but it's really used to tailor the nitrogen program to the in-season needs of the crop. And in my opinion, it's a great tool to use because you can make fertigation applications really throughout the entirety of the crop life cycle, all the way from the early vegetative growth stages through the mid-reproductive growth stages, and be very timely in those applications as well, because you're able to quickly scale across multiple acres with relatively little labor. So it just provides a really great opportunity to fine-tune control of nitrogen management.
And when did you know that you wanted to make a company out of this? It sounds like it was kind of just your research at first, right?
It was. And as I mentioned, we really focused on-farm research. And so from the very get-go, we were working with cooperating producers around the state of Nebraska. And we were simultaneously developing the technology while also validating it in the field. And what that showed over the course of 3 growing seasons was profitability improvement of $23 an acre and a nitrogen use efficiency improvement of 25%. And really seeing those numbers is what ultimately said, okay, we're getting to the end of a grant cycle. We don't want this technology to die because it has really great potential to positively impact farmers and agronomists in a very scalable way. And really the only way to take that forward was to found a startup company. And so that's what I chose to do with the blessing of my advisor back in September 2021. So I actually stepped away. I'd started a PhD and stepped away from that to really take on the company. I'm still technically enrolled, but it's no progress has been made in the last 2 years. I guess we'll say that.
Well, that's okay, considering we're launching a company. I'm sure that's enough to keep you busy. So you said $23 in extra profit per acre. Then what did you say in terms of efficiency?
25% improvement in nitrogen use efficiency.
25% improvement in nitrogen use efficiency. So in order for, obviously, those numbers are very compelling. In order for a farmer to achieve that, what do they have to do? How difficult is it to incorporate this into their normal operation?
So there have been a lot of imagery technologies that have come before us, and there's been a lot of research around sensor-based nitrogen management. Oklahoma State and Nebraska kind of led a lot of that research in the 90s, 2000s, and 2010s. And their two different approaches were kind of the use of a low nitrogen strip down at Oklahoma State to look at crop nitrogen response. Nebraska was a high nitrogen strip to look at essentially what is the crop's yield potential and are we living up to that yield potential with nitrogen. What we've essentially done is fuse those two concepts, and instead of using sensors that were mounted on the boom of a high clearance applicator for a side dress application, we're using satellite imagery captured at daily frequency to be able to essentially measure the crop nitrogen sufficiency in a time series and project out nitrogen demand. And so we've fused a low nitrogen strip with a high nitrogen strip located in strategic parts of the field based on management zones, based on soil data, to calibrate every image and ultimately determine what that crop nitrogen sufficiency is. I say all that to talk about what is the ease of a farmer putting this in. Really what it boils down to is the hardest part of this is working with a farmer to determine which application of theirs we're going to embed that high and low nitrogen calibration into. And ultimately, that's the hardest part of this entire process. We've had farmers do everything from fall anhydrous to strip till to applications in 2x2 at planting to side dress to fertigation to get these plots into the field. And so that's what we've really worked hard to master is how can we scale this calibration approach? Once that's done, the system is running everything autonomously in the background. We automatically contract the satellite imagery. We're automatically assessing every image that comes in to quantify that nitrogen sufficiency, and we're automatically sending out recommendations on the basis of that tracked nitrogen sufficiency to tell the farmer when and how much nitrogen to apply. So that's really ultimately the hardest thing. Typically, field configuration to get that prescription out is about 10 minutes. And so it's a very quick process to get fields configured in the software.
And so which part do farmers struggle with the most then?
One of the key things is making sure you have at least one piece of equipment that can apply variable rate in order to get these plots in the field. Either that or manually adjusting the rate during an application for a field length strip. That's probably the number one thing that farmers struggle with the most. I would say the other thing is just the psychology of a change in how farmers are executing nitrogen management. So many farmers are used to operating on a plan when it comes to nitrogen management. With our technology, we're taking that plan and kind of condensing the plan to, okay, we're going to plan what the early season looks like. So everything until the crop essentially gets to canopy in corn. And then from that point, we're going to let the imagery tell us what the crop needs, right? And so there's a huge unknown of, am I going to need any more fertilizer or am I going to need a lot more fertilizer, right? And so it changes the fundamentals of the buying decisions. When are we procuring fertilizer, right? And it also, it's kind of working against this anxiety of, I've always done this. I've always put this much on and I've always done it at this time. Why is the software saying I don't need it right now? Is it right? Can I trust it? And that's why it's so important for farmers to try it at small scale. We found, typically it's 1 or 2 fields in the first year, or it's with a neighbor that has done an on-farm research trial, because it's very central to what we do is on-farm research trials. But it's really getting close to that farmer, letting them understand and see it. And that's ultimately what leads to the confidence that gets built over time that we can rely on the data to help inform that plan in season.
And are you integrating with any soil sensor or data from physical properties, or is it all just kind of remote sensing?
We are. So there are a few different ways we like to do that. Management zones are kind of a core thing to what we do and how we inform
grid
our practices.
sampling, or
it can be grid sampling. So we do have our own management zone creation tool. We like to take in soil organic matter. We like to take in electrical conductivity maps. We like to take in elevation and slope. We also have several of our dealers that work with swap maps, for example. And so those swap maps get integrated into our processes.
I love the swap maps plug. That's great.
Absolutely. We really enjoy working with them. So if our users have zones they like, we allow them to import those in. And if they think that they represent crop nitrogen response, then we work off of those. So there are several different ways we can do it, but we do like to tie it back, like you said, to those soil physical properties and the topography of the field.
Cool. And are you focused right now just on center pivot irrigation versus, like some of the more specialty crops that might have, other types of irrigation?
Sure. And we're definitely very focused on fertigated grain corn right now, grain silage corn, I should say, as well. And really any corn that's grown under irrigation. We have worked in drip irrigated corn as well. And linears are certainly fair game with this as well. So anything that can really be fertigated, we're comfortable working in. Our prescriptive tools are best suited for pivots right now. We have not put a lot of effort into drip just because there's not a ton of drip irrigated corn. But in general, as long as we can ensure readily plant available nitrogen through fertigation, we're comfortable working in those systems.
Right. And you mentioned, obviously this is suited for variable rate. What's your sense of, and I just don't know this, so maybe it's all of it, but what's your sense of how many center pivots have variable rate capabilities?
It's a really good question, and it's really not a lot. Like, adoption rates are extremely low for true sprinkler level variable rate irrigation. More and more pivots are becoming equipped with speed control variable rate irrigation for sectors. A lot of farmers don't use it, so there's not a high adoption rate there, but at least the equipment is capable of it when necessary. I would say that's one of the key things with our technology versus a lot of other precision technologies that have come before us is we're very comfortable making a full field nitrogen rate recommendation and really focusing on timing in situations where we only have a constant rate fertigation pump and the farmer is uncomfortable using variable rate irrigation. But we can also scale up to the extent of doing zone prescriptions for a Y drop if necessary, which is new this year, right? Or doing variable rate fertigation scripts in pie-shaped sectors. And so there's a wide range of utilities of the system, just depending on what the equipment capabilities are for a farmer and what their comfortability is with variable rate applications.
When did you know you wanted to have a business? You wanted to be an entrepreneur? Was it just like totally opportunistic because of this research you were doing, or is this always been in the back of your mind?
I think it's always been in the back of my mind in some way, shape, or form. I did not think it would be this early. I've never even worked in industry, right? And so I've only ever been in academia. So it's kind of odd to now be in industry, but have a company. I saw my dad be very entrepreneurial growing up. He was a general manager in retail, just regular clothing retail stores for Macy's for a long time. And when the financial crisis hit back in '08, he decided, you know what, I'm going to start my own business. So he went right into the financial crisis, opened a franchise, moved us back to his home state of Alabama. And seeing him go through that journey, there's one thing that he told me that stuck with me was, this has been a really hard road, but a really rewarding road. I think the only thing that would make it better is if I had done it a lot earlier. And so that always stuck with me as, if I have the opportunity to do this, I should do it as early as I can. Because, for him, it was really hard. I've got a family that's depending on me, and I'm starting something brand new. So I felt like the opportunity was right. And having the data, you can't deny like the opportunity for impact. And that's ultimately what was like the push over the edge to pursue it.
Good for you. That's awesome. That is awesome. So tell me about Sentinel Fertigation today as a company. Have you raised some money? Have you built a team? Where are we at today?
We have. So since founding in September of 2021, originally we thought, we were going to bootstrap it as much as possible, take on grant funding, and just slowly get into the market. Anybody that's in ag remembers in 2022, fertilizer prices went crazy. And so we saw that as a tremendous opportunity to get the technology in the market and make an impact. We raised a $1.2 million pre-seed round in April of 2022, backed by a lot of investors from the state of Nebraska. We ended up hiring our first full-time team members, including myself. We hired a senior implementation specialist and a couple of software engineers that are all still with the company today. And then we had our first growing season. We operated on 8,000 acres, saw really good results, got some initial indications of product market fit, did revenue in the first year within the first 9 months, which was amazing. It was backed by on-farm research trials, which helped us to do that. We then added a business growth engineer in January of 2023 and embarked on a seed fundraise. We closed that seed fundraise in September of this last year in 2023. It was a $2.5 million round. So we've raised a little over $3.5 million to date. And moving forward, we've hired a product success manager. We've hired a VP of engineering. We have also hired a data scientist and a second implementation specialist. So we're now up to a full-time team of 9 team members, and have had some additional advisors come on board here in the last few months to help push forward our product and innovation strategy. So things are growing and developing. We're still highly focused on Nebraska and focused on our core market, but starting to explore what that growth strategy looks like longer term.
You're killing it, man. That's awesome. Is the big headwind you're going to run into the lack of adoption of variable rate irrigation?
I think fortunately for us, there are enough variable rate capabilities on machinery coming from the factory right now that farmers at least have the ability, even if they're not using it.
Okay, so it's built in like it is in a combine or something like that. Yeah.
Exactly. And so that ability is out there. It's just a matter of, does the farmer have a reason to use it? And is there somebody there to support that? And with us building our dealer network out, which is a big part of what we're doing, we call it our Century Network, and they're certified service providers is what we call them. We're kind of gearing them up with the expertise to be able to work in these systems, right, and have the expertise to help farmers in taking on and using this technology. So I think really the biggest headwind that we're going to face getting out there is just farmers' perceptions of risk around nitrogen management. Because even if we tell them, hey, you have a $24 per acre profitability increase, right, which is what our last 3 years of data, I was talking about our first 3 years of data initially, but 2021 through 2023 has shown more like $24 per acre increase in profitability. Even with that, farmers see a downside risk of, but what if I lose bushels because I've reduced my nitrogen rate? And if I lose, and right now at current corn prices, 6 bushels an acre, suddenly any sort of reduction in nitrogen is essentially null and void, right? And so a lot of our challenge is overcoming that perception of risk and in as many ways as possible, demonstrating that this will work. There's a high probability of it working on your farm. And that's another reason why we stay in fertigation as heavily as we do right now, because we have a lot of data that suggests that it works. We have good on-farm trials near a lot of pivot irrigated and pivot fertigated corn acres. And so it's easy for us to build on that, build that momentum and leverage those local on-farm research trials to draw in neighbors and to essentially convince farmers they can rely on this working, because that seems to be the biggest headwind that we're going to face.
Right. Well, talk about your experience with Ag Launch and what impact that's had on the trajectory of the company.
Ag Launch has been tremendous. For those that don't know about Ag Launch, it's a farmer-centric model. So they essentially have farmers that invest in companies through their efforts in performing on-farm trials and providing feedback. We participated in the 2023 cohort. And going in, I thought the primary value prop for us was only going to be those farmer trials. But what we really got out of it was a lot of really good business development, connection to mentors in the industry that have helped us to understand what really is the value that we're bringing to the industry. And subsequently, we've been able to work in Tennessee and some geographies where we don't have a lot of experience and found some of the failure points of the technology, just understanding, hey, does imagery really get around clouds? And what are we going to have to do to be able to have a redundancy in place in these cloudy geographies to make sure that we can still deliver good recommendations? And so it's been a really nice way of kind of exposing us in a gentle but productive way to these other geographies.
All right, well, that's going to do it for today's episode. Just a couple of remarkable young entrepreneurs there solving some big problems, but also doing it in what I would consider the right way, which by that I mean focusing on farm profitability first. I really enjoyed both of those conversations. I hope you did too. These are the exact types of stories that continue to motivate me to keep doing this podcast after however many episodes it's been. My point of view is that our industry desperately needs to attract smart, talented, ambitious people like Hunter and Jackson. And it's no secret that it's extremely rare and difficult to just get started in farming because you're ambitious unless you've been born into a bunch of land or a bunch of money. But technology and entrepreneurship can offer another way to make a big impact in agriculture. And I wish both of these guys and all of you listening who are eager to become leaders in the industry the very best of luck and want to continue supporting these efforts however I can. So thank you very much to Hunter and Jackson for these interviews. Thanks to Headstorm for being our quarterly presenting sponsor this quarter. And last but never least, thank you for your time and your attention. I do not take it lightly. I'll be back next week with another story of ag innovation.